Sequences and series. You have done these before. You did them in Chapter 6 last year in Algebra 2. Okay? I know this because we just got done doing Chapter 6 in Algebra 2 last week. Okay? So I know that you've done these before, so this should be a refresher. We'll take it slow off the start, okay? But remember, we're going to be talking about sequences and series. Okay? There are arithmetic sequences and series, which we will handle this today, tomorrow, Monday, and Thursday of next week. Okay, then you'll take a quiz on that. Then on the 6th of March, we will dive into geometric series on Monday, Tuesday, Thursday. And then we will take a quiz on geometric series. Then we'll go into infinite geometric series the following week. And then we'll take a test the week after that. Okay? So, in your textbook, there is a great page, or a great little section of notes that I copied out of your textbook on page 794. If you don't want to write this down, just write down that there's great information about sequences on page 794 of your textbook. Okay? In that first paragraph, okay, a sequence is a function whose domain is a set of consecutive integers. Okay? Starts with 1 and it goes until the sequence is done. Okay? That's the domain of the sequence. That's the term number. Okay? Those are the term numbers. Okay? The actual term is technically the range, or the terms are part of what's called the range. Okay? It's the outputs of the sequence. Okay? Term numbers are the domain. Range then is the terms. Now, this right here is not what you put on stake. Okay? It's not A1. Okay? It's read A sub 1. And then it's read A sub 2, A sub 3, A sub 4, and A sub n. Okay? When you're in math class, you should speak math. Okay? It's not like I go across the other side of up here and I go over into the German room and I start speaking. I'm trying to think of a good fun language. Latin, that's a good one. Latin's a good one. Latin, you know what I mean? Okay? I don't go in there, you know what I mean? When you're in French class, you speak French. You don't speak Cantonese. Okay? Right? When you're in math, you got to speak math. So if you say A1, I'm going to say, yeah, I could really go for a steak right now, too. You know what I mean? Okay? All right? So there's that. Okay? With arithmetic and geometric sequences, there are finite sequences which stop. They have an end. Okay? Infinite sequences go on forever and ever and ever, and what you're looking for an infinite sequence is that dot, dot, dot at the very end. Okay? Now, I will tell you this. Okay? I can write a finite sequence with a dot, 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 and if I put a number after that, that becomes a finite sequence. Okay? If I cover it up, if I just have that is an infinite sequence. But if I put a term after that, now it's a finite sequence again.
So I can guess the dots don't necessarily represent only one, right?
No, the dots represent as many terms as it takes to get to that. Okay? All right? And then on the infinite one, it's just saying that it goes on forever. Okay? We're going to talk more about rules later on. Okay? But, so that's everything that we need to know about sequences. Okay? So, it says, Winter Fun Day, nice try. You already knew that. Okay? If you listen to the announcements, you already knew Winter Fun Day was canceled. Okay? First off, they're not going to cancel school today because if you look outside, that's the sun. Okay?
That's supposed to start snowing till like midnight.
That's the sun. It's that glowing orb in the sky. Okay? Alright, so it says write out the first 6 terms of the following sequences. So, what you do then is you first need to find A sub 1. Okay? Now notice here that I made this n become 1. So n is 1 in this line. If n is 1, then that means that this is 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. So my first term is 7. Okay? Then you go on and you need to find the second term. Now, n is 2. So this becomes 2 times 2 plus 5, which is 9. And you repeat that process until you get the first 6 terms. Okay? Now, to write it out, it needs to be written out in a specific way. Okay? So, this says write out the first 6 terms of the sequence. So, sequences are separated by commas. So, this is 7, comma, 9, comma, 11, comma, 13, comma, 15, comma, 17. And that's it. No dot, dot, dots, no anything else. Okay? Because it only said write out the first 6 terms. Okay? So, if you don't have 6 terms when it says write out the 6 terms, what do you think you are? Wrong. Okay? Okay? Alright? I can't. Oh, I can. Okay? With me? Okay? Over here in this one, write out the first 6 terms. So I'm going to make my first term a sub 1. I'm going to make n be 1. So that's 1. So my first term is 1. Because if I put 1 in for n, 1 minus 1 is 0, and anything to the 0 power is 1. My second term is negative 3. My third term is positive 9. My fourth term is negative 27. My fifth term is 81. And my sixth term is negative 243. So when I write that out, 1, comma, negative 3, comma, 9, comma, negative 27, comma, 81, comma, negative 243. Oops, I missed. Later on, we're going to find that we shouldn't be using A's there for that one, but we should be using G's, because that was a geometric sequence. For today, we'll still use A's. Okay. Handle. Find me the first 6 terms of both of those sequences. You get to feel good inside. So, after the first 3, okay, I kind of see a pattern. It looks like it's subtracting by 2. Okay, so then if I check this one, it should be negative 4, and it is. So if I see that pattern all the way through there, then you could just go right to the fact that this next one here then is negative 6. And the last one, a sub 6, would then be negative 8. If you can see the pattern and you have confidence in your abilities, use it. Okay? So this sequence then would be 2, comma, 0, comma, negative 2, comma, negative 4, comma, negative 6, comma, negative 8. Okay? On the next one, okay, a sub 1 is going to be 1 over 1 plus 1, so that's 1 over 2. A sub 2 then is going to be 2 over 2 plus 1, so that's going to be 2 thirds. A sub 3, 3 over 3 plus 1, 3 fourths. Okay? Looks like I'm taking my term number and then I'm adding 1 to the denominator. So the next one would be 4 fifths. Term number, add 1 to the denominator, 5 sixths. Term number, add 1 to the denominator, 6 sevenths. So this sequence is 1/2, 2 thirds, 3 fourths, 4 fifths, 5 sixths, 6 sevenths. Okay. Those are sequences. Okay. Now, let's take a moment. I'll give you the sequence. Let's take a moment to work ourselves backwards. So the directions in this particular problem say, first, find the pattern, which that would mean that we would want to find that pattern in words. Then it says, write the next term. Then it says, write a rule for it. So describe the pattern. That's going to be words. Write the next term. That's going to be a number. And then write the rule. That's going to be an equation with n as my variable because I want the nth term. Okay, so I'm saying n has to be your variable. Okay? So, find me the pattern in number 5. Somebody give me a pattern. I don't care if it's right or if it's wrong. So you're saying negative term number cubed. Okay? Right? Now, if that's the rule, or I shouldn't say that, if that's the pattern, it's got to work all the way through. Okay? So you're saying that you're going negative term number cubed. Okay? So this is the first term, right? Okay? First term. So then that cubed would be, or so first term would be negative 1 cubed, which is negative 1. Okay? That's the second term, so negative 2 cubed is negative 8. Okay? Third term, negative 3 cubed is negative 27. Fourth term, negative 60, or negative 4 cubed is negative 64. So have we found a rule, or excuse me, a pattern that fits? Yes. Okay? Now, I will tell you this. In the last class, they said for their first guess, and that's why I was kind of hoping that somebody would give me a pattern that didn't work, but you nailed it right on the head. Okay? They said you multiply by 8. Okay? All right? Now watch. Watch. Okay? So they said multiply by 8. And that works right there. Correct?
Yep.
Okay? And it works if I skip over that one term. Okay? But that term is there, so when I go to here, now it doesn't work. So their first guess only worked for the first 2 terms. Okay? That's not a pattern. The pattern has to work on all of your terms. Okay? Just like your rule has to be a rule for all of your terms. Okay? All right? So, if this is the case, made it way too big. Should have went with the smaller one. Why didn't I do that? Now I gotta write words. Now I might as well erase that part too. Hi, caramba.
Okay, small.
Come on.
Small enough one day.
Okay, so then the second part said, find the next term. So we did the first 4 terms, so that means we need the 5th term. So that's negative 5 cubed should be negative 125 for my next term. Yes?
Yep.
Okay. Then, now it says, write the rule for the nth term. So my rule is going to start out a sub n. Because that's my nth term. So that's what I want that to be. I want the rule for my nth term. And that's going to be, now I'm going to go back up here to my red pattern. And my red pattern says negative term number. So that's negative n cubed. And that's my rule. Now, when you make a rule, you should then check your rule with your pattern, and then check your pattern with your sequence. Okay? We checked our sequence with our pattern, and we just translated our pattern into a rule, so we're good here. Okay? But there will come a time in this chapter where I'm going to ask you to find a rule, and you're going to come up with one, and it might only work on 1 or 2 terms, not all of them. Okay? Check it on as many as you can. Okay? Work work on number 6 now. Anybody want to pattern it? What you got?
You add like 2 more every time you add. Meaning like the first one is like you add 2, the second one you add 4, and the next one you add 6.
Okay.
So the next one you add 8.
Okay. So the next one should be 20.
Yes.
Okay. And then what would that rule be?
Term plus 2.
Term plus 2?
So
That's, you know what I mean?
yeah, I know it is this though.
Okay.
I remember doing this last year because there's a certain way to do this one.
Okay. So you're telling me the pattern here is you add 2 more each you add. So plus 2, then plus 4. And plus 6, and so on and so forth. Okay, all right. So according to yours, then the next term should be 20. Okay. But now we struggle to find a rule. Okay. Is there a different pattern that we could see? Can we change up our pattern? Gotcha. Term number squared minus term number. Okay. So first term is 1 squared minus 1 is 0. Second term, 2 squared is 4 minus 2 is 2. Third term is 3 squared minus 3, 6. Fourth term, 4 squared minus 4 is 12. So fifth term would be 5 squared minus 5, right? Which still gets me my 20, right? And now I can write a rule. A sub n is n squared minus n. Okay. Wesley's pattern worked, but it was difficult to come up with the rule.
So you went earlier,
Okay.
you couldn't like estimate like what was down in the future, like if you want to see what like the 20th term would you put down.
Right.
Unless you
Unless you know the rule. Yep. Right? So, okay. Good with that. Okay. Series now. Okay. A series, all a series is it's a sequence that you add up all the terms. Okay. A series is a sequence with you add all the terms. Add up all the terms. Now, there is something out there called sigma notation. sigma notation uses the Greek letter sigma. Okay. And then this paragraph right in here talks all about what I'm about to talk about. Okay? So the sigma notation stands for sum. Okay? So it's for series. Series are sums. Okay? Now, in sigma notation, you have a variable. Okay? That variable is called the index of summation. All that is the variable that you're using. Okay. Then you have some number. Okay. This is going to be a number. Most of the time it's going to be 1. Next most popular is going to be 0. Next most popular is some other number. Okay? That number is called your lower, I'm going to see if they called it bound or limit. Limit. Do they call it lower limit of summation? Yeah, they do. So that's called the lower limit of summation. All you do with that number is, it is the first number you plug into the rule. By plugging that, it's not that number is not your first term. When you plug that number into your rule, that becomes your first term. That outcome becomes the first term. Okay? With me on that? That seems to be the most confusion part. Okay? Your first term is not this number down here. It's what you do when you put that into your rule. Okay? Then you're going to have a number up here above the sigma. That number is called the upper limit of summation. It is the last number you plug in. Okay? So you start at this bottom number and you plug in every integer until you get to the top number into your rule. And then you add them all up. Okay? And then out here is the rule. Draw my arrows. Okay. All of those 4 parts need to be filled in a sigma, in sigma notation. All 4 parts need to be filled. So if you don't have those 4 parts, you need to first find those 4 parts. Okay? So, for instance, on this one, we're going to need a rule at some point in time. Yes? Okay? So let's look at the pattern to find the rule. What's our pattern? We're adding 25. Okay. So my pattern is that I'm going to add 25 each time. So when I go to find my rule, I got basically two choices if I'm adding 25 each time. That first term gives me an n value of 1, right? It's my first term. So it's either going to be n plus 24 to give me 25, or it's going to be 25 times n. Okay, because I got to suffice this one, right? So if it was n, I'll erase these in a minute here. If it was n plus 24, that would give me 25 for my first term. Or it would be 25n would give me 25 for my first term. Now we go to my second term. So now n is 2, so 2 then would be 26, 2 would be 50. Which one is it? 25n. It's 25n. Okay, so my rule here is 25n. Yes. Okay. Did that help, India?
Yeah, I
Okay.
I just
All right. Now, so I need my, if I'm looking at sigma here, okay, so I'm looking at sigma, what variable do you want to use? N? Okay, so if I start n at 1, and my rule is 25n, where do I end? Well, use the rule. Okay. My rule is 25n. My last term is 250, so that was going to be the 10th term if I solve that for n. So my upper limit then is 10. Pattern. Yep. Pattern. Okay, because you got a term number, right? Rule. So then that would be your n over your n plus 1, right? Okay. Do I have my lower limit? Lower limit's 1. Do I have, so I got my lower limit, I've got my index of summation, obviously we're going with n, I've got my rule. Do I have my upper limit? Do I have my upper limit?
No.
It's infinity, right? Because it's dot, dot, dot at the end. So I have everything that I need, so I can go right to sigma notation. Start at 1, end at infinity.
We only need to put that equals to 5.
Correct. Or, like, the book is a big fan of I equals in summation notation. Okay? I don't like using I because I save I for imaginary numbers. Okay? But you could use x equals, and then your rule would have to have x's in it. Okay? Whatever variable you have down here, that's got to be the variable in your rule. Okay? Now, if it says find the sum of the actual series, what you need to do then is you need to find the series first. Okay? So you start by finding the terms of the series. So in this case, a sub 1, I'm going to take my first term and I'm going to plug it in to my rule. So that's going to be 8 times 1, which is 8. My second term, I'm going to plug in 2 and get 16. My third term, I'm going to plug in 3 and I'm going to get 24. My fourth term, I'm going to plug in 4. I'm going to get 32. My fifth term, I'm going to plug in 5 and I'm going to get 40. My sixth term, I'm going to plug in, why?
Because it only goes 5.
Because I have to stop at 5, okay? I've got a hard cap at 5, so I stop right there. So what this is asking then, summation means sum, or sigma notation means sum. The series is 8 plus 16 plus 24 plus 32 plus 40. So what is 8 plus 16 plus 24 plus 32 plus 40? So this is equal to 120. Okay. You now find me number 10. So the debate is, what term do you start at? No. What term do you start at? No. No.
Here, 3. K sub 3.
What term do you start at? Stop what you're saying. Just say the first part. You start at the first term. Because you always start at the first term. Right? Okay? But to get the first term, what do you do? I don't know what this is. No, the first term is not 3. You plug 3 into the rule. Okay? The first term is not 3. The first term, oops, wrong color. The first term, I plug 3 into my rule. Okay? So my first term is 8. Okay? Now, I will write out the rest of the terms. A sub 2 is going to be 4 squared minus 1 is 15. A sub 3 is going to be 5 squared minus 1, that's 24. A sub 4 is going to be 6 squared minus 1 is 35. And my last term is a sub 5, which is 7 squared minus 1, which is 48, because now I've reached my upper limit. You start by putting this number into your rule. That gets you your first term. Then you go to the next integer, next whole number. Okay? Now all the way until you get to your upper limit. Okay? Now, in answer to yours before, because you said we started with a sub 3. Okay? If I asked for the third term of this series, the third term of this series is 24. If you wrote it, like you said you wrote it as a sub 3 first, right? Okay. If you wrote this as a sub 3 equals 8, that's saying the third term of this series is 8. Okay? But it's not. The third term of this series is 24. Okay? Alright? It takes a little bit of logic, but it's not that bad.
Is there an easier way to do this?
No.
I remember seeing this last year. And I don't know if it's weird. It was different.
So then we find 8 plus 15 plus 24 plus 35 plus 48. 130? So we get 130 for my sum. Okay? Both of these are multiples of 3. And then this will be due tomorrow. Oh, I should put on there what it is too. Okay, due tomorrow.